All right, today we are venturing out of chapter 3 finally, and that's a very welcome relief because chapter 3 is very, as we talked about in December, very involved in regards to derivatives and the techniques of derivatives. Um, we're going to go into chapter 4, which will go a little bit quicker, but it's more of an application of the idea of derivatives and how we can work, and not going to be quite as intense as related rates. Related rates was applications of derivatives. We're going to deal more with just graphs in the implication of derivatives in regards to graphing and how we work with graphs. So we have some terms that we may have been introduced to in geometry or in algebra 2 a little bit, and we talked about a little bit in pre-calculus, is absolute maximums and absolute minimums. We're talking about absolute maximums and absolute minimums. The absolute maximum is the value of the function that is the greatest. Okay? You're given a function value f of x, and it maxes out. It has a maximum value. It does not go any higher than a specific value. Or it has a minimum value. It does not go lower than this specific value. Okay, so we talk about absolute maximum, absolute minimum. It's a value that's the greatest or the least that the function can obtain. Okay, we put in values of x and we solve for y. What is the maximum or minimum value a function could obtain? And collectively, we could take a look at this, and they are called extrema. It's your absolute maximum and minimums. When you talk about the extrema, they are your absolute maximums and minimums. Okay, so maximums, once again, think about maximum as just the greatest value the function could obtain, or the minimum is the least value it could obtain. So let's take a look at a function f of x equals x squared. If we take a look at the function f of x equals x squared, hopefully we remember and we recall, looking at the graph of this, we should have a parabola. And this parabola is going to stretch upwards in two directions. Okay, we have our parabola. Y equals x squared. If we take a look at our graph of our function, and a lot of times what I'm going to suggest you do is if you can get a graph down, a picture of what we're dealing with here, you do it. So use your calculator to be able to get that picture. If we look at the absolute minimum, the absolute minimum, well, the absolute minimum is the smallest value that the function could obtain by putting in values of x. So if I look at my values of x here, all my values of x in my domain here, putting in all my values, my extrema is a function value. Okay, it is a function value. What is the smallest value that our function could obtain by putting in any value of x in my domain? Well, we're looking at our y values. Our y values are our function values. What is the smallest y value we can obtain? Okay, that's exactly correct. Our smallest y value is a value of 0. We bottom out here at 0. We don't have any negative values here. If I put in x, -3, -5, -7, doesn't matter. I'm going to get a positive value. My smallest value for y is going to be a value of 0. That's my smallest value. But if I take a look at my biggest value, do I have a biggest value? Is there a cap to my y values? Do I have a value that I'm not going to go higher than that? And the answer is correct, no. because this graph is going to continue onwards, upwards, and it's going to continue to increase my y value. So I have no absolute maximums because I don't peak out. Well, we can also take a look at extrema on a closed domain. I have an x value of 1. I have an x value of 1, and I have an x value of 4, and I include these values. So I have a value of 1 and a value of 4. So we are looking at this interval a closed interval from 1 to 4. On my closed interval from 1 to 4, what are my absolute maximums and absolute minimums? Well, once again, I'm looking for my y values here. What is my biggest value for y? What's my smallest value for y on this interval? Well, I could take and go back to my y-axis and be able to find these values on the y-axis. And they'll give us our absolute maximum minimums, our extrema, on just this interval. If I look at just this interval, my biggest value for y is going to be 4 squared, or 16. My absolute minimum will occur at my x value of 1. So we have it at 1 squared, or a value of 1. So we have absolute maximum extrema on a specific interval. Well, what would happen if I would open up? If I would open one up? Well, I would still have an absolute max at 16. But I would not have an absolute minimum, an exact value for my absolute minimum. The reason why is we can talk about the idea of limits if we want to. The limit as x approaches 1 from the left and say, well, our minimum value would be 1, but we never quite achieve 1. We could say our absolute minimum is the limit as x approaches 1 from the left. That would be our absolute minimum, but there's no definite value there because I can say it's 1.000000001, but I can get smaller than that by adding in another 0, and smaller than that by adding in another 0. So I can't get an absolute minimum there. We could talk about local maximums and local minimums. When we talk about local maximum minimums, we've dealt with these before. We've just never called them. When we were graphing our trig functions, our sine and cosine functions, we had what we call peaks and valleys. When we have peaks and we have valleys, these are called local maximums or local minimums. Now, when you talk about the idea of local, it is an interval a small interval of the domain. So we're going to take a look at just an interval on the domain. And this will give us what are called local maximum and local minimums, which are our peaks and our valleys. And this small interval is pretty much determined by you. Well, how small do I want to make this interval? For example, here I have a peak. I have a peak here. So I can make my interval from -1.5 to -2.5. I have a valley here, so I can go from 0.5 to 1.5. And I can talk about the maximum on that interval or the minimum on that interval and get what is called a local max and then a local min. If I want to go -1.75 and -2.25, that's fine. If I want to go -1.9 or -2.1, that's fine. I localize to a specific interval, and I have a small interval. Well, with this, what we can call is we can talk about what are called critical points. Critical points. These are the values from the domain that make our first derivative of a function equal to 0. Critical points. They're values from the domain that make our derivative of our function equal to 0. These are called critical points. Values from the domain that make the derivative of our function equal to 0. What makes f prime of x equal to 0? These are called critical points. And what we will do is we'll look to tie in the ideas that we had from the previous chapter into this chapter. And we'll tie things together. Because we've talked about derivatives. Okay? Talked about the derivatives. But now we're going to specify, we're going to say what we're going to put our derivative equal to 0. What meaning does that have? And then we'll tie it into the idea of local maximum and local minimums. On a closed interval, if, it should be an if. On a closed interval, if no critical points exist, then the absolute extrema will occur at the endpoints of the interval. On a closed interval, if no critical points exist, then the absolute extrema will occur at the endpoints of the interval. Take a look at the function f of x equals x squared minus 2x minus 3. This is going to give us a parabola. Let's see. I have a y-intercept at -3. My axis of symmetry will be -b, -2/2a. So we have an axis of symmetry at 1. We're going to get an axis of symmetry at a value of 1 here. Let's see here. At a value of 1, I would have a value of -4. So here would be our graph. Okay, we have a parabola. We have a vertex point of the parabola at -1, -4. That's my vertex point. We want to take the interval from 0 to 4. So we're going to take a look at the interval from 0 to 4. And if we take a look at our parabola, from 0 to 4, my parabola from 0 to 4 is this portion right here. We want to find the extrema on that interval. Well, if we take a look at the value of 1, we bottom out. So we have what we call a local extrema, or a local minimum. We have a value there. We have an interval from 0 to 4. If no critical points exist, then the absolute extrema will occur at the endpoints. Well, let's take a look at the critical points. Well, how do we find a critical point? From the front page, our critical point occurs at our derivative. So what we take a look at is our critical point. We set our derivative equal to 0. What's our derivative here? We have x squared minus 2x minus 3. Our derivative would be 2x minus 2. Solving for x, we can add 2, so 2 is equal to 2x, so x would equal a value of 1. So what we have here is we have a critical point. We have a critical point at this value of 1, which is this bottom value right here. It's the vertex of the parabola. So to find our local extrema on this interval, what we have to test is our endpoints and our critical point. We have our two endpoints and we have our critical point. Well, if I find my function value at 0, I get a value of -3. If I find my function value at 4, we get 16 minus 8 minus 3. So we have 16 minus 8, which is 8 minus 3. We have a value of 5. If I find my function value at 1, I have 1 minus 2 minus 3. I get a -4. To find my extrema on this interval, we look at these 3 points. We look at our endpoints, and we also look at any critical point. Here's my smallest value, so this is my absolute minimum. Here's my biggest value, so I have an absolute max at this value. So I have my absolute maximum, I have my absolute minimum on that specific interval. Local max and local mins, our local extrema, can only occur at critical points. They can only occur at critical points. And what we're going to do is we're going to stop there today because I want you to work on your absolute maximum or absolute extrema. We'll get more into the critical points and the ramifications of that tomorrow. But on your homework assignment today, you have on page 203 or 283, 284, 29 to 61, the odds. You're just looking at extremas that are on there, and we'll look more at local max and local mins and what the critical points have and classifying them tomorrow with the first derivative test. But that'll be more tomorrow. So you can start working on your homework. That would be it for the day with respect to local max and local mins. Adios. Have a good day.